Okay, this is lesson 7.2, and this is the present value of an annuity. The way present value of an annuity works is the present value of an annuity is the principal, so it's how much money you need to invest today so that you can make a regular withdrawal called a regular payment. So I just want to look at the scenario and then we'll come back to the equation. So if we look, Victor wants to withdraw $700 at the end of each month for 8 months, starting 1 month from now. His bank account earns 5.4% per year compounded monthly. How much must Victor deposit into his account today to pay for the withdrawals? So the way this works is if you want $700 every month for 8 months, well, you can do a little bit of quick math here and say, well, $700 and you want 8 of those is $5,600. So you need $5,600 in order to withdraw $700. But the thing is, if you're taking advantage of the fact that banks offer you interest, you don't have to put $5,600 into the bank. You can put a little bit less and earn interest on all that money that's in the bank so that you can make that $700 withdrawal every month. So it's taking advantage of interest to save you a little bit of money in the long run. If you know you're going to need that money, if you have some money now and you don't want to just hang on to it and then pay yourself $700 every month for 8 months, put it in the bank, take advantage of interest, and withdraw the amount as you need it. That's how this scenario works. So let's first look at the equation. The equation is missing some information here. Big square bracket right here. Minus sign after the 1, and the key here is a minus sign on the exponent n. The nice thing about present value is r, I, and n are all the exact same thing as they were in future value. R is still regular payment. I is still interest rate per compounding period. And n is still number of compound periods. All right, let's try to use the equation. In order to use the equation, oh, I forgot about PV. PV is the present value. Let's try to use the equation. Back to the Victor example. Victor wants to withdraw $700 at the end of each month. Withdraw $700. That is important because that's one of our variables. We want to find how much must Victor deposit. That's PV. We want to find that. The other dollar amount is R, the regular payment. We've also got at the end of each month for 8 months, and we've got 5.4% compounded monthly. These are the important pieces. So we're making 8 deposits. So that means the number of compound periods is 8. That's how many times we're making a deposit. I is the interest rate per compounding period. And here's the tricky one. The interest rate is 5.4%. So that's 0.054. But that's not I, because we don't get 5.4% every month. We get 5.4% every year. We're compounding monthly, which is 12 times per year. So we're not getting that whole interest rate every month. We're getting that interest rate split up into 12 parts, and we're getting part of it every month. So we must divide by 12. We're dividing by whatever this amount is. And that becomes the key to figuring out what I is. In any question where you have to find either A or PV, your first step is going to be to figure out what I is. And I is always whatever percent you're given divided by whatever the number is after compounded. If it's monthly, that number is 12. And now we can use the equation. So refresher, the equation is R square bracket, round bracket, 1 minus round bracket, 1 plus I, negative n exponent, close bracket, all over I. And the key here is that negative n exponent. Don't forget it's negative. When you use your calculator to get the negative n, you must use that negative sign in a bracket or that plus minus sign on the calculator. It's one of those buttons. If you use subtract, it may not work. So be careful. All right, let's fill in what we know and calculate our present value and answer the question, how much does Victor have to deposit today? Well, 700, square bracket, round bracket, 1 minus, round bracket, 1 plus, 0.0054, negative 8 is our exponent, close bracket, all over 0.0045. The biggest mistakes I see when people do these questions is I. They get the wrong I. They either use 0.054 or they forget to make it a decimal and they use a percent, which is wrong. All right, we're going to type this whole thing in our calculator. It's the easiest way to do it. If not, do the whole top and then divide by the bottom. But we got 700, bracket, bracket, 1 minus, bracket, 1 plus, 0.0045, close bracket, exponent button, and we want negative 6. And the key is on my calculator, it's this negative button, not subtract. Oh, and it's not 6, sorry, 8. And close bracket, and down on the bottom we got 0.0045 equals, I made an error. Weird. Let's go look. Uh-oh, gotta type it all in again. Wonder what my mistake was. Maybe you saw it, maybe you caught it in the video. Let's try it again. 700, bracket, bracket, 1 minus, bracket, 1 plus. Oh, I see. Oops. This bracket. Definitely not supposed to be there. I don't know why I put it there. There we go. That should solve it. 0.0045. Close bracket. Exponent, negative 8. Close bracket. 0.0045. Hey! $5,488.28. All right. So as we calculated earlier, Victor, if he just paid himself $700 8 times, would be paying himself $5,600. But if we do some planning and taking advantage of the interest rate of the bank, we don't have to deposit $5,600 in order to pay ourselves $700 every month for 8 months. We can deposit a little bit less than that, for $5,488.28. How much less? Well, that's called the interest. So you might be interested to figure this out. The way you can figure it out is you can take how much money Victor paid himself, $700, times how many times he paid himself, that's 8, and subtract how much Victor put in the bank. And if we do that, we get 11172, which is how much interest Victor earned by planning. Okay, that's it for present value of an annuity. Thanks for watching lesson 7.2, and I'll see you for our last lesson, 7.3.